Hello, my name is Sharvika Raut and I study at Sardar Patel Institute of Technology. In this video, we will be discussing the implementation of power management scheduling algorithm in a heterogeneous multi-core SoC. So now the question arises, what is an SoC? SoC is nothing but a system on chip, which is essentially a complex IC that integrates major functional elements into a single chip. The functional elements can be an 8051 microcontroller, amplifiers, filters, USB and whatnot, as seen in the diagram. So now let's discuss why this project. Since we all know that temperature affects not only the reliability but also the performance, power and the cost of the embedded system. Power management of safer and reliable systems is hence the need of the hour. But presently, multi-core systems are power hungry due to dead codes, which causes power wastage. Hence, power becomes of utmost importance when the size and the expected duration of the system is huge. For instance, satellite and the automotive industry. Hence, the essence of our proposal will be a system which will be power aware and thermal aware. Now let's see the objectives. The first and the foremost objective is to evaluate heterogeneous parameters on the basis of power consumption, temperature, task duration and the CPU load. It is also to implement time scheduling algorithm, which is basically a fundamental principle of an RTOS. We also aim to synchronize and establish communication between two different cores and then evaluating temperatures on the separate cores respectively. This will in turn avoid performance lag and the time lag, which will make the system faster and safer, and it will be reliable and power efficient, of course, because the scheduling will be based on the power and the thermal consumption, the real time consumption of the tasks. We also see that the real-time analysis framework will be used to design and to analyze an effective method to reduce the peak temperature. Now we see that the formula for power in the CMOS processor is given, and we see that F, which is the clocking frequency, is the only variable in the whole formula, and we directly see that P is directly proportional to F. Since F is a changeable and a tangible entity, I can change my power consumption based on my frequency. If I increase my frequency, the power consumption will be more. If I decrease the frequency, the power consumption will be less. We aim to use an energy plus technology for this, provided by Texas Instruments. Thank you so much.